No gym, no gym, no gym, no gym. If you get below 90. All right, lovely people, welcome to the channel. This is Professor Bene. If you haven't subscribed, be a believer, subscribe so that you can get more videos. All right, so we are continuing with Sun, Earth, and Moon systems. Previously, we talked about the solar system. The solar system is made up of the sun at the center, with all the planets, the other planets, and other objects revolving around the sun. We also talked about the fact that the mass of the sun is about 99% the mass of the entire solar system. One sun, our sun, can hold a total of about 1,000,000 Earth. So 1,000,000 Earth can fill the sun. So that means the sun is very big, is very huge. The volume of the sun is very big. The volume and the mass of the sun is very big. Okay? The mass is about 99% the mass of the entire solar system. Previously, we also talked about rotation and revolution. And we said the Earth rotates on its axis. It takes 24 hours for the Earth to rotate on its axis. And that's what defines the length of day. We also talked about revolution. The Earth revolves around the sun, and that takes 365 days to complete one revolution. That's what determines the length of 1 year. We also talked about seasons. What determines seasons? And we said that the tilt of the Earth is tilted at an angle. That tilt and also the revolution of the Earth around the sun, that's what determines seasons. Okay, so we are going to continue our discussion and talk about latitudes, longitude lines, how they affect the length of daylight. Okay, so what determines seasons, we already know that is the tilt and also the revolution of the Earth around the sun. Those are the two key things that determines seasons. Okay. So latitude and longitude lines. Longitude lines, they are imaginary lines that run from north to south. So these are longitude lines, imaginary lines that run from north to south. North is the upper part, south is the lower part, as you can see on your screen. Okay, so longitude lines, they are lines that run from north to south. Latitude lines, they are lines that run from west to east. Latitude lines, they run from west to east. The prime meridian is at 0 degrees longitude. So this is the prime meridian. It's at 0 degrees longitude. The equator is at 0 degrees latitude. The equator is an imaginary line that divides the Earth into two equal halves. The northern hemisphere and the southern hemisphere. Okay, so here we see a diagram below that represents a portion of Earth's latitude and longitude system. Here point A, and point B here are locations on Earth's surface. All right, the arrows, they show the direction where the Earth is rotating. So the Earth is rotating from left to right. It's rotating from west to east. All right, so the question is, if it's known at location A, what time will it be at location B? So if it's known at location A, that means it will be afternoon at location B. The reason is location B is ahead of location A. So that means location B will be ahead of location B in terms of the time zone. Okay, so here we are looking at compass directions. The north represents the top parts here. So our head, if you look at the parts of the body, our head part of the body represents the north. Our feet or lower part of the body represent the south. The left side represents the west. Right side represents east. And between north and east, we have northeast directions. Between north and west, we have northwest directions. Between south and west, we have southwest directions. Between east and south, we have southeast directions. Okay, so here we are looking at hurricane directions. Okay, so we are looking at hurricane direction from day 1, day 2, day 3 through day 4. So it says, the question is, in which compass direction did the hurricane travel from day 1 to day 4? So if you look at the direction from day 1 to day 4, the hurricane traveled from day 1 to day 4. In the compass direction, we are moving from the right hand side to the left hand side, but it's between the north and the west, so it will be the northwest direction. Okay, so from day 1 to day 4 means the hurricane travel from northwest direction. Okay, it's between north and west, so it's northwest direction. Okay, so we are still looking at latitude and longitude lines. All right, the equator is at latitude 0 degrees. Okay, so let's move on. Compare the latitude and longitude at location A and location B. Compare the latitude and longitude at the location of city A and the location of city B. So if you look at location of city B compared to location of city A, are they on the same latitude? Are they on the same longitude? Remember, longitude lines, they run from north to south. Okay, latitude lines, they run from west to east. So looking at the location of city B compared to location of city A, they are on the same latitude but different longitude. If you look at it, they are on the same latitude but different longitude, and we can estimate that to be about latitude 43 degrees north. Latitude 43 degrees north. Okay, so the question is, what happens to the air temperature as latitude increases or move away from the equator towards the poles? What happens to the air temperature? Does it get colder? Does it get warmer as you move away from the equator? The equator is at latitude 0 degrees. As you move away from the equator towards the poles, you are moving towards the poles. What happens to the air temperature as latitude increases? As you move towards the poles, the latitude line, they increases. So from 0, equator is at 0, 20 degrees, 40 degrees, 60 degrees, 80, 180, and moving up. So as you move away from the equator and towards the poles, what happens to the air temperature? And as you move away from the equator and towards the poles, the air temperature decreases. The air temperature decreases because as you move away from the equator and towards the poles, the amount of sunlight intensity decreases. Previous lesson, we also talked about this. We said that the amount of sunlight decreases because it's more spread out at the poles. At the equator, the sunlight hit the equator with more directly, almost at 90 degrees. So there is more sunlight intensity at the poles than at the equator than at the poles. And that's the reason why the equator is warmer compared to the poles. So as you move towards the poles, the air temperature decreases and it gets colder as you move towards the poles. So here we are looking at latitude lines. All right. So these lines, they represent latitude lines. Virginia Beach, New York City. So these lines, they represent latitude lines. We also have this image representing latitude lines. Okay. The question is, determine the number of hours and minutes of daylight for Virginia Beach and New York City on December 31st. So if we look at the graph, December 31st, all we need to do is to look at where the graph crosses, the latitude lines crosses the point for December 31st. So that for Virginia Beach will be 9.4. So that means 9 hours 40 minutes. This is where it crosses, that latitude line crosses. For New York City will be 9.18 or 9 hours 18 minutes. 9 hours 18 minutes for New York City. All right. So if you look at it, the length or the number of minutes of daylight hours, they are different for New York and Virginia Beach. So New York and Virginia Beach is 9 hours 40 minutes. New York is 9 hours 18 minutes. So that means New York is less compared to Virginia Beach. Okay? Less daylight hours compared to Virginia Beach. All right, so here it says describe the general relationship between the latitude of a location in the United States and the length of daylight in December for that location. So what is the relationship between latitude and also the length of daylight? All right, so as you move towards the poles, as you move away from the equator towards the poles, latitude lines, they increase. All right, so here latitude lines, they are increasing, and as latitude line increases, the length of daylight hours, they decrease. Okay, so as latitude lines increases, the length of daylight, they decrease. The reason is because of the amount of sunlight reaching the poles. At the poles, they are more spread out. Okay, so if they are more spread out, there is not enough sunlight reaching the poles compared to the equator. The equator is at 0 degrees, and as you move towards the poles, latitude lines, they increase. And as latitude line increases, the length of daylight hours, they decrease. And it also gets colder as you move towards the poles. Okay? So these are relationships that we should always remember, that the equator is at 0 degrees latitude. As you move away from the equator towards the poles, what happens to latitude lines? Latitude lines, they increase. Latitude lines increase. And as latitude lines increases, the length of daylight hours, they decrease. The length of daylight hours, they decrease. So if you look at this graph, let's look at these latitude lines. Okay, New York is at 40 degrees latitude. Virginia Beach is at 35 degrees latitude. So which of these lines is closer to the equator? Virginia Beach is closer to the equator compared to New York City. So that means that Virginia Beach will be much warmer compared to New York City because Virginia Beach is closer to the equator. Sunlight intensity rate in Virginia Beach will be greater. So that means as you move from Virginia Beach towards New York, latitude lines, they are increasing. And as latitude line increases, it gets colder, right? Because the sunlight intensity decreases as latitude increases. So as latitude is increasing, it gets colder because you are moving towards the poles. And that means that the air temperature decreases because of the amount of sunlight intensity reaching New York City compared to Virginia Beach. All right. So the length of daylight also decreases for New York City compared to Virginia Beach. The reason is you are moving away from the equator towards the poles. There is less sunlight intensity. Okay. There is less sunlight intensity. All right. So we need to know the relationship between latitude lines and longitude lines. Okay. Latitude lines, remember, they run from west to east. And as you move towards the poles, latitude lines, they are increasing. Okay. They are increasing. And as latitude line increases, the amount of sunlight reaching the poles becomes less intense. And if it's less intense, that means less sunlight reaching the place. It gets colder if it's less intense. And